Okay, we're looking at an applied problem, the effect of advertising on profit. It says the quarterly profit in thousands of dollars of Cunningham Realty is given by P of x equal minus 1/3 x squared plus 7x plus 30, where x ranges from 0 to 50. X is in thousands of dollars, and it's the amount of money Cunningham spends on advertising per quarter. Money spent on advertising per quarter in thousands of dollars, and the function calculates the profit in thousands of dollars per quarter. Okay, now I've got a graph here of the profit function, and look at that just for a minute. You'll notice that when x is equal to 0, in other words, there's no money spent on advertising per quarter, the profits are around 30,000. Matter of fact, if you look at the function and put x equal to 0, it is 30,000. You can see the y-intercept, or the profit p-intercept there on the vertical axis is around 30. Now, it appears also that the profits increase. This is a quadratic equation with a vertex. It opens down. The profits are increasing as I start to invest money per quarter into advertising, and all the way up to just beyond $10,000. It appears it continues to increase and reaches a maximum at that point. And then it begins to decrease. The profits per quarter decrease as the amount of advertising dollars go beyond 10,000, and then continue to decrease. It also appears that a little bit more than $24,000 invested per quarter in advertising will actually start a loss in profits. In other words, there isn't much benefit to investing more than $10,000 plus dollars. We could actually find out the amount if we found the vertex, but the problem is really asking us for the rate of change of profit, or how fast the profits per quarter are changing as our investment in advertising changes. So to answer a question like that, I'm going to have to find the derivative function, p prime of x, and I'm going to use the derivative formula here. I'm going to evaluate the profit function at x plus h. So every place there is an x, I'm going to substitute an x plus h. Then according to the formula, I'm supposed to subtract the function. This has 3 terms to it, so make sure that you get parentheses around there, or make sure you subtract each term. If you want to subtract the whole function and it has 3 terms, you need to subtract each term. So let's see now, p prime of x will be the limit. I'm going to go ahead and simplify that a little bit. The first term there, the minus 1/3 times the quantity x plus h squared. X plus h squared, that quantity is x squared plus 2xh plus h squared. And then I got to multiply the whole thing by a minus 1/3. So I'm going to do that at once. I'll have a minus 1/3 x squared and a minus 2/3 xh, and then a minus 1/3 h squared. I'm going to distribute in the 7, so 7x plus 7h plus 30 plus 1/3 x squared, distributing in that negative, minus 7x minus 30 all over h. So p prime of x equals, I'll get a little cancellation here, limit as h approaches 0. The minus 1/3 x squared and the positive 1/3 x squared cancel. The 7x and the minus 7x, and the 30 and the minus 30 cancel. So I'm left with, in the numerator, minus 2/3 xh minus 1/3 h squared plus 7h all over h. And then factoring out an h from the numerator, I'll have h times a minus 2/3 x minus 1/3 h plus 7 all over h. H's cancel. And then I have p prime of x finally is equal to the limit as h approaches 0 of minus 2/3 x minus 1/3 h plus 7. As h goes to 0, that middle term will vanish, and I just have minus 2/3 x plus 7. So p prime of x equals minus 2/3 times x plus 7. So I have a derivative function that will calculate the rate of change of profit per quarter given the amount of money spent in advertising. One question they have here is, suppose that $10,000 is invested in advertising. How fast, or what is the rate of change of Cunningham's quarterly profit if the amount it spends on advertising is $10,000? Well, remember x is in thousands, so I need just to calculate p prime of 10, and that would just require me to replace the x with 10, and I get 0.333 repeating. So the profit is changing at, let's see, in dollars, that would be $333.33. Remember, we're talking that the derivative or the profit function is in thousands, so that would be $333.33 per $1,000 per quarter. So $333.33 per quarter. Now let's look at that. At x equal to 10 on the graph, we have calculated the slope here, and it's a slope of the tangent line at 0.333, and in other words, the rate of profit is increasing, not by a lot. You can tell that a little bit more investment, it wouldn't be increasing at all. It would have reached a maximum. But it's still increasing at 10. And the next question is, what is the rate of change of Cunningham's quarterly profit if the amount spent on advertising is $30,000, or x is equal to 30. So I've got a minus 2/3 times 30 plus 7, and I've got, with that, comes out to be a minus 13, or it is decreasing. We can interpret that negative as decreasing $13,000 per quarter. Now let's see where that is. 30 is here, over here on the graph. And you can see that the slope is much steeper there. The curve, the function is much steeper. It's changing much quicker, although that's a negative slope. Whereas over here at 10 again, the curve is not changing very rapidly. The slope is small. It's a positive slope. So the profits are increasing a little bit at a small rate. But again, over here at 30, the profits are negative. The tangent line, the steepness of the profit function at x equal to 30 is fairly steep. The function is changing pretty rapidly, and it's also a negative slope. The profits are decreasing at a rate of $13,000 per quarter. Okay, now that's an example of a derivative applied to a function that's estimating the profit.